Hi, welcome back to the pre-calculus lecture series. And this video, we are working on the second part of the chapter 4 practice test. Previous video, we did about 6 problems, so we still have 4 more problems to finish, and 3 of them are the word problems and where they are the application problems about the exponential function and the log functions here. Okay, so let's go ahead and start. Okay, so let's go back to my practice test worksheets here. Okay, so for these ones here, they tell you, here they say, hey, I'm giving you the value natural log equal to 3 is 1.0974, natural log equal to 2 is 0.6931. And now I want to find the log 27 with base 12. Okay, so like in here, we don't have a calculator, so how do we do it? So in here we say we can use the change the base series, right? So because I don't have a calculator for the 27 with the base 12 is here, but they do give us the natural log function. So I would say, hey, let me change this to the change base. I would say this is a natural log 27, and then this is natural log 12. Well, this is still not good enough because I still need to use the only information they give us is natural log 3. Then you say, hey, 27, I can deal with. So 27 is 3 to the third power, correct? Then the natural log 12, I can change this one to a 3 times 4. Okay, so now in here, so this one's here, you move this one down. So this is 3 natural log 3, right? By using the laws of the logarithm. Oh, this is good because after I do that, this is natural log 3, and I know what is natural log 3 is. I can plug that in. Okay, so this is a multiplication. So in here, I can change it to natural log 3 plus natural log 4. So I have the value of natural log 3, but I don't have the value of natural log 4. So I need to still think about how to do that. So the natural log 4, I say, hey, I can change it to the 2 to the square, right? So now I can do that. So this is 3, this is natural log 3. Then these ones here, I can move to the front. Yeah, now I can have the 2 to the natural log 2. So I change this both, the whole expression with the natural log functions here. So now I will have, so what here, you just substitute 3 times 1.0974, then this is 1.0974 plus 2 times 0.6931 here. It's good. All right. So if you put it into your so you can, use your calculator, or you can just carry that out. This is 1.3256 here. Okay, this is how do we use the change base formula to find the values here. Okay, so then the remaining 3 problems are very interesting problem, are the word problem. Okay, so these ones here, they said the initial size of a culture of bacteria is 1,000. After 1 hour, the bacteria turns to be the 8,000. And they want to find the functions, the N to N0 ERT, model the population after the T hours. When you do those type of problems, the very one thing here is those units has to match, all right? The how many, like the rate change units, and you want to find it has to match here. Okay, so in here, we know, in order to find it, right? So let's say 8,000, right? So I'm going to turn the 8,000 when the initial is 1,000, right? So it's 1,000 E. I need to find my rate of the change. So this is E to the R. Then the T's here is how many, the time frequencies. So T here is hour. So here they're looking for the hour. So that's fine. So initially I only have 1 hour, correct? Okay, so now you've divided by this, so I will get here, so it's 8 is equal to the E what? ER, And now I take the natural log both sides. So I will say natural log A is equal to what? Is R, right? So my rate of the change is really high. It's 2.0794, okay? So now I can write my equation. So I say N is equal to the 1000 E 2.0794 times T here, okay? So part B, they ask, what is the population is after 1.5 hours? That means what? That means my T right now is 1.5. So you plug in. So this is 1000 times E. This is 2.0794 times 1.5, right? Okay, so then you can put it into the calculator and it will give you, this is 22,626.00. All right. Now the C is here. Let's say how many hours the, the bacteria going to reach like a 15,000. That means you want, this is 15,000 and this is 1,000. And the E, the R is 2.0794. You want to find what? You want to find the T's here, right? So you want to find the T's here. Okay, so let's see, how do we do this? This is basically become to solve the equation of the exponential, right? So you divide 1000. So it's 15 is equal to E to the 2.0794 times T. Now what you need to do, log, natural log both sides. So it's natural log 15 is equal to the natural log E 2.0794 times T. Here, here is good because E and the natural log cancel. So what I have here, I will have, this is 2.0794 T. So you divide by 2.0794 divided by 2.0794. So what is the T here going to be? T is going to be natural log 15, 2.0794. So very close to 1.3 hours, right? So it's a little bit more than 1 hour here. So this is how do we use this exponential formula here. Okay, let's take a look at the next one, problem number 9 here. So let's say that suppose $12,000 is invested in a saving account and they pay an interest rate of 5.6, right? So this is my R. Write the formula, okay, for the years, if interest compound, oh, this is a compound interest, right? Compound monthly. So remember the compounding interest here, we say it's P1 plus what? R over N and the NTs, right? So N is how many times you're going to compound per years, right? Okay, so now for the A, we can write it. So what is my initial principal? Is 12,000, okay? Then you times 1 plus, so what is the R here? 5.56, so this is 0.056. Now, they say compounding monthly here, right? Compounding monthly, that means what is my N's here? Hey, it's 12, right? Then we say the NT is how many years, right? So this is will be 12 times T. So that will be my part A here. Let's take a look at part B. They say find the amount after 3 years if it's a compounding. So this one is compounding differently. It's a daily. All right, so then let's take a look at how do we do compounding dailies here. So you will say this is 12,000. Okay, so this is 1 plus 0.056 daily. How many days in a year is 365. Okay, then how many years? 3 years. So it's 365 times what? Times 3 here, right? So you put all this into your calculator, you will get something is 14195.06. That means after the 3 years, your $10,000 will increase to what? To 14,000, something like that. Okay, so now part C is here. They say, how long will it take to the amount to grow to the 20,000 if interest rate is compounding, continuously? So what is the formula for the compounding continuously? So we know the compounding continuously, the formula is A is what? PERT. That's right. So now let's say how long will it take is to the 20,000. So that means my A is 20,000, starting with 10,000 as my initial. So then ER is what? 0.056 times T, right? Okay, so now you divide by here, so you will say the 2 is equal to the E.056 times T, correct? Okay, so I'm sorry, this is 12,000, Okay, so this is 12,000, I did not pay attention. Okay, so this is 12,000. Okay, so the 20,000, so the 20,000 divided by 12,000, this will be 5/3, right? So it's 20,000 divided by 12,000. So this is 5/3. Okay, so now how do you do to solve it? Hey, take the natural logs, right? So we'll say natural log of 5/3 is equal to natural log E.056 times T. And these ones here, they cancel. So that's pretty cool. That's what is the natural log function is. And then we will say this is a natural log of 5/3 equal to the 0.056 times T. And then you divide by 0.056, 0.056. So what is the T's here? T is natural log of 5/3 over the 0.056. And it's about 9.12 years. So it takes about 9 years to, change to the 20,000 here. All right. Okay. Let's take a look at the number 10 here. So let's say the half-life of the krypton Kr is 10 seconds. So let's highlight the key information. 10 seconds is a half-life. At the time T, a heavy canister contains 3 grams, and the T is 3 grams of this radioactive gas here. So find the functions MT model this Kr remain after the T seconds here. Okay, so the first things here, right? So we still use we say A is PERT. So this is the formula we use, right? So first things we need to understand what is the half-life. Half-life, that means, initially you have a P, then you turn into the half P, right? So this is initially, right? So this is the ER. So how long it takes to the half-life is 10 seconds here. That's what we mean the half-life here, right? Be careful here. Half-life, that means you have this much, this much radioactive gas there. After 10 seconds, they only have a half of that. That means 1/2 here. All right. Okay, so now that's why you can have here. So this is 1/2, right? Equal to E the R times 10, right? Okay. Now what I need to do is here, hey, I need to take the natural log. So it's a natural log of 1/2 is equal to the natural log here. And so this is natural log e the r to the 10th, right? So natural log cancel. This is r to the 10th here. All right. And then r, what is the r? So you want to solve for your rate, right? You want to solve this rate r. So what is the r here? So you will say the r is equal to what? 10 over natural log 1/2. Okay, so let's do a little bit of changes here. So this is 10. Natural log 1/2 is what? It's 2 to the negative 1s, right? Right, so it's 2 to the negative 1. And then this one here is 10, 1/10, basically is natural log 2 to the negative 1. Am I right? Okay, so you'll be able to do what? You can use the law of the logarithm to bring this one back to here, okay? So now the r, I can rewrite the r. Here, so I can, okay, so let's take a look here. So I can rewrite the r is equal to the natural log 2, the negative what? 1 over 10. That's right. Am I right? All right, so it's a negative, right? So here, okay, so now you can plug in into your functions here, right? So let's say the MTs here is equal to, take a look at they want to find the function M0, right? So this is the M0 and the ERT. So M0 is initial is how many grams? 3 grams. And the E, then the R, I just get here, is a natural log of 2 to the negative 1/2 times T. And also, I cannot just cancel here. I need to move this T to the inside. So this is natural log 2, negative T, and here's 10. Now, finally, I say, okay, E and the natural log, I can move here, right? So I can cancel that out. And so when you cancel that out, what do you have? You have 3 times, right? So you have 3 times 2 to the negative T over what? T over 10. All right, so this is your answer A here. Okay, so now that's why they say if you want to put the ERT, so what is the that one's going to be? So this is part A, they want to specifically put in the 2, that's why. So for part B, they want to just put a PERT. So then you will say this is MT, you can just put what is 3 grams, then E, then you say it's a natural log, what, E to the R, what is the R here? R is the natural log 2 over 10 times T here, okay? Now part C, so let's say how much KR left after, after 1 minute here. Okay, so now I can say after 1 minute is MT. So this is the initial 3 times. I can use either one. I like to use the first one, it's easier. So it's 2 negative. Now be very careful. What is my T's here? Let's say is 1 minute, right? But my T, in here, I'm based on the seconds, right? So this is a 10 seconds. So I need to switch the T to seconds. So 1 minute is how many seconds? It's 60 seconds here. So you need to replace the T with 60, then this is 10. And then you put it into your calculator, it will give you 0.04675. So it's about this much grain left after 1 minute. Okay, so but part D says how much longer? So how long will the things going to the amount of the KR will only reduce to the 1 microgram. 1 microgram in here, let's say it's 10 to the negative 6. Okay, so let's plug into the formulas here. So MT, that means 1 microgram. So it's 10 to the negative 6 is equal to the 3. right? So times 2e to the t to the 10. Okay, so divided by 3, both sides, divided by 3, divided by 3. So I'll have a 10 to the negative 6 to the 3 equal to the 2 to the negative to the 10. Now, what is the next things we need to do? Hey, I need to the natural logs, both sides, right? So I say natural log 10 to the negative 6 to the 3 is equal to the natural log 2 negative 10 over t over 10. Then move this, the whole constants to the front, right? So this is negative t over 20 natural log 2. Okay, so then you can solve for t's, right? So you say, then the t, right? So in here, you have a natural log 10 to the negative 6 to the 3 equal to negative t and 20 natural log 2. So you can say the t is equal to the negative. Okay, so you divide it by natural log 2 times 20, and this is natural log 10 to the negative 6 to the 3. All right, then you put it into the calculator, you get about 430. So be careful, what is this? This is seconds, right? So 430 seconds is approximately to the 1.17 minutes. Okay, so it's take about 7 minutes for this radioactive gas to reduce to 1 micrograms here. Okay, so basically all these 3 application problems try to use the formula, the PRT formula we try to do. Okay, and I hope this help you to understand the problem and help you to practice. And so how to set up those exponential decay and exponential growth type of the problems here. Okay, that's it. And hope you have a good understanding for this practice test, and good luck for your real test there. Okay, bye, and talk to you later. Okay, bye-bye.